Good evening, everyone. Am I audible to everyone?
Yes,
Just
you're audible.
raise your hand if am I. Sorry.
Yes, sir, you are audible.
Okay, thank you. All right. So let me just quickly share my screen with you. Okay, Tejas, thank you. Okay. Can you all see my screen now? Yes. Okay. Perfect. Okay, Vandana. Thank you. All right. So I hope you all remember me. My name is Abhishek, and I took the introductory class of all of you of the introduction to penetration pen testing. I don't know how many of you are still here from the first class.
Yeah. Hi, Abhishek.
Yeah, yeah. Hi, hi, hi. Yeah. Actually, it will be throughout the lecture. I will be interacting with all of you in just one way. So you don't have to open your microphone. You can just type in the comments, type in the chat. Okay, I'll see it because if even two or three of you open your microphone at the same time, it will be a problem. So just keep your microphones off, and I'll look at the chat if whenever required. Okay, I'm good for you. Okay, let me just present to you. So I took the introductory class of all of you where I told you that what are the steps in penetration testing, what is basically pen testing is, what are the steps. We talked about number of steps. The first was reconnaissance, and then there was scanning networks, then was something else, then something else, and something else. You know how to get access, how to first of all scan, gather data about different systems across a network, then how to scan the networks. We didn't deep into talked about how to scan networks yet, but we talked about the certain steps. You know, like there's a recipe for everything. In the same way, pen testing is like a dish, and there's a certain step. There are certain steps called recipes for it. The first one was reconnaissance, where we collected data. I hope you have, all of you have attended that first lecture, which was reconnaissance, and in which we gather data about different our targets, like the IP addresses, the website name, employee details, and all. How to do social engineering and all those things to gather required data to move further into the process. The second process would be the second step in this pen testing process would be scanning networks. So all of ethical hacking, pen testing, or any subdomain under this is related to networks. Okay, if a machine is not connected to any type of network and is just isolated, we cannot do much about it. We can only find vulnerabilities and exploit it when we get it on our hands. Otherwise, remotely, we cannot even touch it because it's not connected to any network. So a machine has to be connected to network. In today's world, almost everything is connected to networks. Fortunately for us, pen testers, it's a good sign. Everything is connected to networks. Without network, we cannot communicate with each other. So there is no use of a machine. Like there is someone living up in the town, he's using his mobile phone using networks. If there is no SIM card on his mobile phone, the phone is useless, right? If he's using internet, then he's connected to network. So any device, almost every device is connected to a network. We have our televisions on in a home, they are connected to network, satellites. All right. So almost every electrical device that communicates with each other is connected to networks. So scanning the networks is a crucial part. Once we gathered enough information about the target, one more thing I'd like to tell all of you that scanning network is considered unethical if we do not have required permissions. So let me just quickly tell you all of you beforehand. Scanning networks, or that is why we call it ethical hacking. We're doing it ethically under rules, under permissions. So whenever we are scanning a particular network, we must have the permissions to do so. Otherwise, it's illegal and unethical. You cannot just go somewhere, someone's like you cannot go someone's into someone's house and just start searching for things. He'll be like, "What are you doing?" He'll immediately call police, right? You cannot just go into someone's house, someone's kitchen, scanning things. Okay, I found this, I found this. No, you cannot do this. You need permissions to do that. In the same way, in the network system, if you're scanning a network, we'll talk about what is a network, what do I mean when I say a network, what do I mean when I say a host or a server. We'll talk about that. So whenever you're scanning a host or a server, we need permissions. Okay, but before scanning networks, we must know what are networks. Okay, so we need some foundational networking concepts before we move further into the realm of ethical hacking or pen testing or whatever. So now we know that most of the devices that are connected to network, we can only play with those devices which are connected to network only. Okay, we cannot play with isolated devices. Okay, so networking is important. That is why foundational networking concepts are required. Basic networking concepts. What do I mean by that? Well, I mean what is IP addressing, what are network protocols, what are network security measures. We'll talk about that briefly in this slide. So make sure I'll just touch upon these topics briefly, very briefly, and this will be your homework, kind of a homework for you to explore more about these networking concepts. Okay, so it will be a comprehensive overview. The presentation aims to provide a basic understanding of networking concepts and how they relate to ethical hacking, like IP addressing, network protocols, and network security. So first, let's talk about IP addressing. So an IP address is a unique identifier assigned to each device on a network. Okay, that was the definition. What does it mean? Let's understand it with an analogy. Okay, so let me just go back and look for some names. Okay, there's Praveen connected with us. There is Karthik. There's Subha Sarkar. Okay, let's say I want to call Subha. I want to call Subha and talk about how's the weather there, how everything is going. So, what do I need to call Subha? You can comment down your answers. Karthik, I already know their name. I just said Subha. How do I call Subha? I'm sitting here. How can I ask Subha questions? How can I connect with Subha? Yeah, and Vesh Pal, right? Exactly. I can get a calling number. I can ask Subha what's your phone number, and then I can call and ask certain details. Yeah. So I need a phone address. A phone address. What is a phone address? What is a phone number? A phone number. It's just a numerical data, of 10-digit numerical data. Unique. It is unique. In the same way, I want to ask Sanjay. I want to send some parcel to Sanjay. What do I need? A physical thing I want to send to Sanjay. I have some sweets. My mother made some sweets. I want to send to Sanjay. What do I need? I need address. home address of Sanjay so that I can parcel all the details. Yeah, yeah, Vivek, Sagar, right, Priyanshu. I need the Sanjay's home address so that I can send deliveries to their house. In the same way, in the network's topology, in the network realm, we need address. What do we call this address? We call it IP address. Okay, so each device, every device you see all around you, your laptop, your smartphone, your servers, they have a unique address. It's called IP address. All right. So, like Sanjay's home may be in Uttar Pradesh, Lucknow. So we can say, okay, gully number 2, Hanuman Chowk, Uttar Pradesh, or Bihar. So this is how home address looks like. IP address do not look like because it's a machine address. So it's not like my laptop will be in Delhi all the time. No, it can be anywhere. So it's not related to. It's not like a home address. It's a different kind of address. A 32-bit numerical address. How does it look like? Well, it looks like something like this. It's an example of IPv4 IP address. We'll talk about what is IPv4 means. But just right now, just think of it IP address. Okay, so IP address looks like this. This it has three dots. I hope you all can see this. So it has three dots and four octets. And using this configuration, we can create 4.3 billion unique addresses. All right, so most of the devices all around us have an IP address assigned to them so that they can communicate. If my computer wants to send a file to some other computer, how does it communicate? Well, my computer says, okay, give me the address of that person, of that device's IP address to whom you want to send this data. So I'll say, okay, this is the IP address of that particular computer. Now send the data. That is how devices communicate. They need IP addresses, not home addresses like the humans. Okay, so using this configuration, however, I can only create 4.3 billion unique addresses. Like all the devices in this world we have created so far, all the computers, laptops, smartphones, devices, they can we can only assign them addresses up to 4.3 billion unique addresses because we are limited by this configuration. But in today's generation, we have a lot of devices, more than 4.3 billion devices we have. So how do we assign unique address to each one of them? We cannot because we are limited by 4.3 billion number. That is why industry have now started using IPv6 address. It was called earlier it was called IPv4 address because there were four octets in it. A new version of it is have been started using in the market, which is called IPv6 address. So most of the devices now have address to them assigned in the sixth version, V6 version. It looks something like this. Okay, it consists of alphanumeric data. It has numbers in it. It has alphabets in it. And why do we need IPv6 address? So that we can assign more addresses to a growing number of devices. Okay, so how big of a number it becomes? Now, earlier we had 3.4 billion unique addresses. We could have 4.3 billion unique devices, but using IPv6, we now can have 340000000. I can't even count the number of zeros. This number of billion unique addresses we can create using IPv6 addresses. That is why industry have now started using IPv6 address because we have run out of IPv4 addressing. Okay, the basic difference is nothing. It's just same IP addresses. We have just transitioned from IPv4 to IPv6. Okay, so again, it's nothing but just addresses of devices. Just like we have home addresses, we have IP addresses of devices. All right, so we have now understood what our IP addresses are. Okay, next go to network protocols. What are network protocols? Well, okay, before understanding what network protocols are, let's take a different analogy. When we are communicating with a friend, we speak in a different way, right? We are chill. We are not a little serious. We are chill. We are laughing. We are showing our teeth. We are making jokes. We are using a completely different type of body language, relaxed and all, right? When we are communicating with a friend. But while we are communicating, discussing some topic with our faculty member, a teacher, we are a bit serious. we have a different way of communicating with them. We use, a rigid body language. We use different tone. We don't make a lot of jokes in front of them, right? We don't show our teeth all the time. So there's a different set of rules we use while talking to our faculty member, and then we use a different set of rules while communicating with our friend. In the same way, in the network world, we use different set of rules according to the type of communication we are doing. These rules are called network protocols. For example, if I'm transferring a file from one device to another, what I'm doing, I'm not talking, I'm just simply transferring a file. I'll use a different set of rules to communicate. Okay. So my device will say my laptop, let's say my laptop is sending some data to a different laptop, a different desktop or a computer around the world, and it is right now sharing data. So it will say, okay, I'm sharing data, so this set of rules I will use. This set of network protocols I will use. If I'm not sharing data, I'm let's say I'm sharing a mail, I'm sending a mail. So my computer will say, okay, I'm not sharing some data, I'm actually sending a mail. I use different set of protocols. So just like we use different set of protocols while communicating with different people in our daily life, the networks, the devices use different set of protocols while communicating in the network system. What are these type of protocols? These protocols can be TCP/IP, STTP, FTP. Again, I told you that we'll briefly touch upon these topics, so you'll have to do your homework. You'll go deep into these topics. So your homework will be what is TCP, transmission control protocol, what is internet protocol, IP, what is STTP, hypertext transfer protocol, what is FTP, file transfer protocol. These are all the protocols which you need, which are essential for ethical hacking. Okay, I've also listed down some of them here. Give me a second. So these are some of the network protocols. There are a lot more than this, but I've just listed the essential ones like transmission control protocol. What is it? It is nothing but when building a communication, a connection with a different device on a network, we use different set of rules. Okay, and network protocols are just that. If I'm transferring a file, it will use a file transfer protocol. Okay, if I'm sending a mail, it will use a simple mail transfer protocol, SMTP protocol. If I'm communicating, if I'm using a website right now, if I'm communicating with a website, I want to visit facebook.com. So when I type in facebook.com, I'm using hypertext transfer protocol, STTP protocol, or HTTPS protocol, whatever it is. Okay, so these are the network protocols. The next is network security. Now, this is I hope a lot of you already know what network security measures are. Like network security refers to the measures taken to protect a network from unauthorized access or attacks. Okay, if I'm trying to exploit or find vulnerabilities on a network, I should also know how to protect my own network, so that once I found the vulnerabilities, I should tell the organization, okay, these are the vulnerabilities I found on your network, and this is the network security measures you can take. This is how you can protect your network in future. So what are the measures we can implement? Like we have firewalls. Firewalls, you may most of you may already know what a firewall is. It's a secure software or designed in a system which prevents unauthorized access to our network. Okay, it has IDS inbuilt in them. What is IDS? It is intrusion detection system. It actually uses patterns, already known patterns. It uses those patterns to check if someone is trying to access our network. If he found some suspicion, he found the target to be suspicious, he'll block it. So if I'm trying to access some network without authorization, the firewall will find it, and if the firewall find it suspicious, it can block me. So that is how you can protect your network from unauthorized access. Okay, we can also use VPNs, that is virtual private network. What does a VPN do? It can do a lot of things. It can change our location. How it can change our location? If I'm accessing a network, the network will know which IP addressing is trying to enter into its domain. So if I'm let's say if I'm entering someone else's IP address in a network, he'll know that okay, some guy from Delhi is trying to enter our network. What does VPN do is VPN change the server. So right now I was in Delhi, but the VPN changes the location. The VPN will show okay, some guy from Poland is trying to enter the network. I'm trying to access the network from Delhi only, but the VPN has changed my geolocation and is showing from some country. The network will see okay, some guy from Poland is trying to access my network. So this is how we can protect our safety. You can protect ourselves from this network authorization thing using VPN, firewalls, intrusion detection system, and all. Okay. So let's talk about the main thing of today, that is scanning networks. How we can scan networks. Before scanning networks, there is one thing I want to tell all of you about. It is about ports. So let's say I have a laptop I'm using right now. I'm using internet on my laptop. So imagine my laptop as a hotel with a number of rooms. Okay, a number of rooms. Each room does its own job. Each room is different from one another. Each room has a different task assigned to it. As I told you earlier, if I want to transfer a file from one device to another, my computer will use a different room for that. It will say, okay, room number 34 will be used for file transferring. Okay, no other room will be used for it. If I'm sending a mail to someone, okay, room number 20 will be used for sending the mail. Okay, no other room will be using it. If I'm communicating with the website, if I'm saying okay, I want to access facebook.com, I do not want to download any data or upload any data. I just want to surf the internet, surf the web facebook.com. So room number 80 will be used for that. So that is how our computer divides this network task according to rooms. These rooms are called ports. Okay, so these are ports. We should know what ports are. Ports are nothing but just a way of connecting with different computers using different set of rules. So ports, a computer divides a network into a number of ports. Okay, just like in a hotel, we have different rooms. Each port has its own job. If one port is assigned for transferring data, it cannot send mails. That port won't be used for sending mails. Okay, each port has its own job. Now, scanning the networks. Let's get back to scanning the networks. What do I mean by scanning the network? So let's say I have access. There is a network in our schools. In our schools and our colleges, we had networks connected in a LAN network. Different computers were connected in a LAN, local area network. All of them were connected. So let's say if I get using the reconnaissance, the first part, we get information about those that organization. Okay, my school had this. I got to know about my school uh, LAN network. There are a number of computers connected with each other. I just got IP address of one such computer. Okay, I now have, using the first reconnaissance part, I have gathered information. I now have IP address of one such computer in that network. I want to check if that computer is right now, is that computer connected to the network or not? Okay, so first thing is I want to check if it is connected or not. Second thing I can check is how can I exploit that. I now know that the computer is connected. Okay, I got to know that the computer is connected to the network. What do I do? I can find vulnerabilities in the network. Okay, I get access to all the connections in that network. What do I do with it? I can find vulnerabilities. What are the open ports in that network, in that host? Okay, the network, the LAN setup in my school is using internet and using all type of file transferring, because yeah, right, because one file, when okay, you I didn't told you about server and client. It is nothing but just like you had in your school, we had a main computer where our teacher used to sit and the students would sit on different computers. So imagine the teacher, where the teacher used to sit, it's like a server. Okay, the teacher had a server. Okay, it's the main computer that is the head of all the computers, and all the computer were the host. So all of them were connected to the main computer. Whenever if I transfer a file, if I install a software on my server, all of the host, that is the computers connected with the server, will get the file directly, will get the installation directly. So this is client server model we use in LAN networks. This is also being used in internet. This is how internet also works. The client server model. There is a server, then there are clients. Like we all are clients, right? When we access Instagram or Facebook, what we are doing is we are opening, we are opening our account. We are sending a request to the server, asking server, okay, show me my username, show me my photos that I upload, show images that people who I follow and people who have followed me, show their photos, show their data. So I'm a client and I'm requesting data from the server. This is a basic client server model that is used on the internet and also in the LAN server and all. So the server is the main thing. Okay, so I got to know about the IP address of one such client. So I got to know about the address of IP address of one such client. What do I do now? I can check how many hosts are connected to that network. Okay, host, I mean clients. That is the host. There can be a number of hosts, and the main is server. Okay, how many hosts are connected to this server? How many hosts are active on the server? If active, what do I mean if I say active? I mean if it's really connected to the server or not. I must have. I may. It is possible that I have got the wrong IP address, or maybe the IP address that I got of the computer is not really working, not connected to the network. So first thing is checking if the device is actually connected to the network or not. If it's not connected to the network, we cannot do anything. Okay, we cannot do nothing if a device is not connected to a network. Remember that. We can only access something remotely if it's connected to any type of network. Okay, so the first job is to check if it's connected to the network or not. The second would be a lot of things. We'll talk about those a lot of things later in the video. But right now, first task is to check whether the host is alive or not. It is connected to the server or not. The IP address we got is right or not. Okay, so there are number of tools we can use in scanning the networks. What are these tools? The tools name are Nmap, Wireshark, and Metasploit. These are just three tools I listed down. There are a number of tools, and again, this will be your as a kind of homework to do a quick, brief research on what are these tools, what do these tools do. Today in this lecture, we'll only talk about Nmap and the basic commands used in Nmap. Okay, so yeah, let's use the Nmap right now. You can download Nmap directly on your computer by typing nmap.org. Free tool available over the internet. You can go to the download section, and according to your machine, you can download if it's using Windows, Mac, Linux, or any other operating system. It works on all of them. Okay, so I have installed Nmap on my system. I have opened my lab right here, so you can see. Okay, so here's the Nmap. It's called ZenMap in Windows. Actually, it's Nmap, but for the graphical user interface with GUI, it's called ZenMap. It's nothing but a graphic GUI version of Nmap. All right. So this is Nmap. I've also installed it on my computer. I can check it here, like Nmap. So it's installed here. I can also use the command line interface or the GUI version, whichever suits well for you. So this is how the Nmap looks like. Graphical version of it look like. Okay. A job is to check the IP address that we collected is alive or not. What do I mean by that? I want to check the IP address that we collected is connected to the server or not. First job is this. What do we do? I've written down some commands here. We'll use those commands. Okay. Let's use the first command. Okay, so this is the command section of Nmap. Here you can see command. Okay, here we can just type Nmap. Okay, whatever the commands I'll type in this box, this command box, you can type all these commands in the command line interface also. Okay, you can type them here. All right. Okay, it will work exactly the same. It is just the GUI version of it. Okay, so I want to scan a network. I have a scan particular network. I want to scan whether it is alive or not, whether it is connected to the network or not. How do I do it? I'll type nmap. I'll type. Okay, let me just quick delete it. Delete from here. Okay, what does I type in sn, then I type in dash sn, I type in nmap dash sn dash pu. What does this command mean? Well, I'll talk about that in a moment. But just as of now, just remember this. I type in nmap, the name of the software that I'm using, dash sn dash pu, and then the IP address that I want to scan. So I want to scan 10.10. This is the IP address of my local server, the machine that I'm using, and I'll just press enter. I don't know if you all can see it right now, if it's visible clearly. So this is the data that we've received. Okay, so we'll read it from the bottom. Whose mic is on? Okay, you can read the data from the bottom. It is shown that one IP address, one host is up, scanned in 0.0.09 seconds. It scanned the network, the IP address that I typed in, which is 10.10.10.16. It is the IP address of my server. I type in the IP address and I type in the command nmap.sn.pu. What does it mean? We'll talk about that in a moment. But right now, just remember this. This is the command I typed in. This is the IP address that I wanted to scan. Okay, what does it show? It shows that and starting nmap 7.80, the version of nmap, and this is the time that it took. Okay, 2023 Eastern Daylight Time. Okay, next is nmap scan report for this. It has scanned the network in 0.09 seconds and it has given us a report. It says host is up. What does it mean? It means yes, the server is connected to the network and is receiving data packets. That means it is connected to network. So the first thing, the first task is completed. We wanted to check if it's really connected to the network or not. If it's not connected to network, if it shows host is down, then we have nothing to do. We couldn't do anything. Okay, let's say, let's say, let's say if I type down some IP addresses which is not connected to network, what would it have shown? It would have shown this. No, host seems down. If it is really up but blocking up ping and blah 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 blah. But we know that the machine is not connected to the network. That is why it shows host seems down. So if you type in the IP address of any device which is not connected to any type of network or a server which is not connected to any type of network, it will show host seems down. Okay, but if it is connected, what it will show? It will simply show the host is up. Okay, so now that we know the host is connected to the network, we'll do form a second task. What do we do after that? Let's say I do not have a single IP address to scan, but I have a number of IP addresses to scan. There are a number of hosts I have. What do I do in that case? So I have another IP address. Let's say I have two IP addresses to scan. What do? I've already typed in the command here. I can just simply type another IP address like 10.10.10.17. Let's say I have another one. Let's say I have another one 10.10.10.18. I want to scan these three IP addresses. It'll what it'll do is it'll show all these three IP addresses. It says three IP addresses scanned, one host is up. So out of these three IP addresses, only one is up. So this is how it's scanned. Which one is up? Well, 10.10.10.16 is up. All twos are down. But let's say I have a number of IP addresses, like 30 to 40, maybe hundreds of IP addresses to scan. What do I do in that case? Nothing. I can just give it a range. I did it in this whiteboard. I provided it with a range 10.10.10.11 to 20. Scan me all the networks in this range of 11 to 20. Right? The command is completely same. The IP addressing, I have not provided a single IP address. I am providing a range of IP addresses like 10.10.10.11 to 20. Scan all these IP addresses in this range. I'll type in the enter, and it's so fast. It just took 0.50 seconds, and it scanned all these 20 10 IP addresses. So it will show you all the IP addresses that are on right now, that are receiving data packets. Like here you can see 10 IP addresses scanned, 4 hosts up. Out of the 10 I provided to scan, only 4 are up. Which one are those? Well, 10.10.13, 14, 16, and 19. These 4 are up. You can see here, host is up. All right. But what about the those which are not up? I can also see which are not up by providing a dash v command. It's called verbose output. Okay. So in the command, I can also type in dash v. I didn't do anything with the command. I just type in dash v, and we'll talk about those PO and SN. Just don't worry about that. I just type in dash v. Okay, it will provide me the details of all the devices that we scanned, whether they are up or not. So I just press enter. So earlier it only showed IP addresses which were up like this. 13 were up, so it showed host is up. But this time it also showed us the host which were down, like 10.11 host is down, host down. 13 is up, 14 is up, 15 is down, 16 is up, 17 down, 18 down, 19 is up, and 20 is down. Okay, so dash v is called verbose output. It says, okay, give me information, all the information, not just about the host which are up, also give me information about hosts which are down, but scanned anyways. Okay, so let's now talk about what is SN. Well, scanning the networks, okay, I got to know about which hosts are up, which hosts are down. What do I do after that? I now know that this IP address is connected to a network. What do I do after it? There's nothing much to do. Well, there is. I can check which ports are open on that machine. What do I mean that by that? I mean that if the machine is receiving data packets, that is, it is connected to network, then it must be communicating with other machines, right? And in order to communicate with other machines, it must be using its ports. Remember those hotel rooms? If it's exchanging data or information with other devices, it must be using one of those rooms. So what can I do using port scanning is I can check which rooms they are using, which ports they are using right now to share information and gathering data. What will we do after port scanning? We'll talk about that. But right now, I want to check which ports are open so that I can get to know what information they are communicating, what type of information. I won't get access to which website they are using, which website that device is using right now, but I'll get to know, okay, this guy is using the internet right now. This person, this device, this server is exchanging data using this port right now, and that is enough data for me so that I can find vulnerabilities and exploit it. So how do I do that? How do I check which ports are open? Well, this SN commands restricts us from doing that. I have been typing in SN. SN means I do not want to scan the ports. Okay, so once I remove the SN command, I'll also get details about open ports. So let me just quickly remove all of this. I'll type nmap dash pu. What is pu? We'll talk about that in a moment. I have removed the SN command. Earlier, when I was using SN command, it was telling the nmap, okay, do not scan ports on these networks. I just want to check if they are connected to the network or not. Okay, but this time I have removed the SN command. So this means I also want to check the open ports. So nmap dot dash pu and dash then my IP address, which is the target IP address. In my case is 10.10.10. So starting nmap, again, all those same things, the timings, nmap scan report for this particular IP address. It says host is up. So it also performs a host discovery. So it says host is up, and these are the ports that are open right now on this particular machine. Which ports are open? Like, okay, these are the ports open: port number 53, port number 80, port number 88, 135, 139, and so on. All these ports are open. That means using these rooms, this machine, this particular machine, this 10.10.10.16 machine is exchanging data and information with other machines. It is receiving and requesting data and information using these ports, these all ports. These ports and these services may seem a little intriguing at first to you, right? So again, you can get to know about these ports and their details a lot over the internet and using your own homework. Like I told you that port 80 is used for HTTP. That means this machine is using right now, this machine that I'm using right now is requesting and serving data over the internet, a website. It's using a it's the machine is right now requesting responding to data. Some host is connected to this machine, it's asking for data, and this machine is responding to the request and sending data on port 80. HTTP port is used to serve website and web. Okay, so right now I got to know, okay, port 80 is open. That means this machine is exchanging data over the internet. Okay, exchanging information over the internet. This is what port 80 means. Port 80 does nothing except website surfing, responding data and requesting data. That is what port 80 is used for. And I now know that port 80 is being used in this machine. I can find vulnerabilities and exploit it later. But scanning network part, in the scanning network part, we only scan the network. We don't, do certain things with that. We'll do those in the next steps, in the upcoming steps, like third step, fourth step, fifth step. The first part was reconnaissance, scanning the network. No, scanning the gathering data about the network and the target. Second part is scanning the network. You now have got to know about certain hosts in a network, certain servers in a network. What we'll do now is scan that network, find vulnerabilities, find open ports in it. So right now we have found open ports. Okay, so let me quickly tell you about this -pu command that I typed in here. What does -pu means? It means, okay, whenever I told you earlier that whenever I'm communicating with different machines over a network, we use different type of protocols. The device basically use different type of protocols. Okay, if it's coming like we humans do. If I'm communicating with my friend, I use different set of rules, different use set of body language and tone. If I'm communicating with my teacher or some senior authority, I use different set of protocols. In the same way, devices use different set of protocols while communicating with different machines. In this case, I'm asking the machine by typing the -pu command. I'm asking the machine, okay, whenever you're connecting with this machine, that's 10.10.10.16. If you're communicating, because how does it check if the host is up or not? It sends a signal, right? It sends a request. So I'm asking the machine to, okay, perform a UDP scan. Now, what is a UDP scan? It's a protocol, user diagram protocol. There are different protocols I told you about. Uh, TCP protocol, transmission control protocol, UDP protocol, user diagram protocol. The TCP protocol is a three-way connection, a three-way handshake protocol, in which we send the request. If I want to check a server is online or not, I send a request. Okay, okay, are you there? So the server will respond, yes, I am here. And then I'll respond, okay, I have received the request. I know that you are there. So it's a three-way handshake. So in the cases where in those cases where I need the data integrity, I want connection to be perfect so that I can transfer data. I will use TCP protocol because I need guarantee of the network. Okay, so this is, but TCP is a bit slow because as you can see, it requires three-way handshake. I asked the server, are you there? The server responded, yes, I am here. And then I responded, okay, I got to know that you are here. Let's make a connection. It's a TCP connection. UDP is not like that. UDP doesn't care if the server is there or not. UDP just sends the data. Okay, so it's a much faster way of communicating, but it's less reliable. So according to our needs, according to the needs, the device use different set of protocols. In this case, I don't want to send data and all. I just want to do it quickly. So I am using dot dash pu command, which means UDP scan. I'm not doing a TCP scan. I'm doing a UDP scan. Again, you'll have to do a little bit of homework. You'll learn about. You should know about how these protocols work. What are the differences of these in between these protocols? When which protocol is used when, okay, according to the needs, according to which machine or what type of data I'm transferring, which type of machine I'm communicating with. So do a little bit of homework, but just right now make sure I type nmap dash pu, which means do a UDP scan and then the IP address of my machine. I also didn't use sn command, which means I told nmap also do that. You should, apart from doing host discovery, also do port scanning, and that is what nmap did. Nmap did a port scanning, and it found these many open ports. I now know the host is up. I now know these are the number of ports available. That means open in my machine, in my target machine. Okay, moving forward, we have did the port scanning. We can also do is operating system discovery. It is called OS discovery. All right. So let's say if I've gathered IP address of a device in a network, I want to check which operating system the device is using. How do I do that? Well, Nmap also provides that commands. I can type nmap dash a and the address of my IP address of my target machine. I can just type nmap dash a 10.10.10.16. What does A means? A means aggressive scanning. When I press enter, it performs a scan, an aggressive scan. It finds all the details about the machine, like what is the computer name, what is the BIOS details of that computer, what is the operating system that it is using, what are the network details. It will give you all the details. But since it is using an aggressive scan, it is using a lot of it is providing us with a lot of details. It will also take a lot of time. So it usually takes around 20 to 12 minutes to scan. Okay, but let's say if I do not want BIOS details, I do not want network details, I just want to know what operating system it is using right now. In that case, I can simply use, instead of A, I can simply use O command, dash O. It stands for operating system. And I can just simply type in, press enter. So I typed in nmap-o and the IP address of my target machine. Again, I didn't put the .sn command. That means it also performed port scanning. All right, you can see it. And it also shows host is up. It also did host discovery. And if I scroll down below, you can also see it also showed me what operating system am I using right now. It showed me I'm using Microsoft Windows Server 2016. It's actually a server. The target IP address I typed in was of a server. Okay, and what server what is the operating system of my server right now? It is Microsoft Windows Server 2016. All right, you can also check it on your computer system by typing opening a command prompt. And first of all, we'll check about our IP address. nmap-o and the IP address of your machine. Here you can see the IP address of my computer is Microsoft Windows 10. Okay, and these are the ports open on my computer right now. Running Microsoft Windows 10, device type general purpose, operating system is Microsoft Windows 10. Host is up. All right, and this was the IP address of my device. You can check your IP address by simply typing ipconfig, ipconfig, and you'll see IPv4 address of your device. Okay. All right, so this is how we can do operating system discovery. So these were the basic commands we use of nmap today. So we got to know about so what we do, we did network scanning. If I know details of a network, a host in a network, like IP address, and know the IP address of a host or a server in a network, I can do following things. What I can check if the host is alive or not. What does it mean by alive or not? It means if it's really connected to the network or not. Okay. The second thing I can do is it's port scanning. I can do is port scanning. I think we did port scanning, right? Let me check if we have the connection here without SM. Like here, we did the port scanning. We also did the host discovery. We also did the port scanning. We can do port scanning to check which ports are open on our machine, on our target machine right now, so that we can exploit. How we can exploit these open ports and find vulnerabilities, we'll talk about that in subsequent lectures. Okay, in the following lectures. As of now, our task was just to check if the host is alive, how many ports are open, and also what is the operating system of my target machine. If I want complete details, I can type in the dash v command, like verbose command, to check details of all the target machines. Okay, this is useful. Nmap is useful because we are not only checking a single IP address. We may have a number of IP addresses, like maybe hundreds or 200s. We can check operating system of all of them, right? I'll just type in the okay, I just did a typo here. We can just provide it with a range of IP addresses and press enter. It will show all the details of all these IP addresses. Like I asked, okay, give me the details of 11 to 20 IP address range, give me operating system of all of them. So it will take a little bit of time, but it will give us details. So this is what we did in network scanning. Okay, so here you can see details of all the networks we did. Yeah, it also shows us MAC addresses. Okay, MAC address is what? MAC address is nothing but is a physical address assigned to our network interface card. All the devices have network interface card through which they communicate with other networks. It's a physical machine component. It also has a physical address assigned to it. It's called a MAC address. Okay. So, all right, this was it for network scanning using Nmap. But Nmap has a lot of more commands, which I like want you all to practice on your own. How you can practice, how you can get to know about all these commands, just go to your command line interface of whichever software you're using. Okay, and just type in nmap dash dash help. Right, it will show you all the details. You can all the commands you can use. Here you can see I typed in nmap help. It's the name of the version that I'm using, and these are target specifications. If I want to do host discovery, I can use these commands for host discovery. All right, if I want to do as OS detection, I can do these commands. Okay, I can do a number of things. Okay, if there is a okay, my device, my let's say my target device that I'm trying to scan has a firewall installed in it, has an IDS installed in it. The IDS of the firewall can block Nmap from accessing the network details. So Nmap may show that the host is down, while in fact the host is up. In that case, we can use certain commands to bypass firewall, like this: S spoof source address dash f and dot ss. You can use a number of commands for that. Okay, so you can your assignment. This is again your homework. You can go through all these commands, and whenever you are doubt, you can just type in nmap dash dash help. It will help you. Okay, where you can get nmap, you can just go to your any web browser, type in nmap. It will show you details. nmap.org. All right. So there are other softwares also available, other tools like Nmap, Metasploit, or Wireshark. But primarily Nmap is used because it's robust, lightweight, and very fast. That is why people in the industry use Nmap a lot. So that was it for today. I hope you all understood what network scanning is, and please go through the network foundational concepts for ethical hacking. Foundational network concepts, like we talked about IP addressing, network protocols. Network protocol part is really important. All these TCP, UDP, IP protocols, HTTP file transfer protocols. Go through them, please. Okay, for a better understanding of how Nmap works. All right. So this was it. This was the foundational network concepts which were essential for ethical hacking. We talked about Nmap, how to use Nmap. The basic thing you can do a lot of with the nmap by typing all the commands, and make sure to use that nmap dash a command. Nmap dash a command, make sure to use it. All right, because it's an aggressive scan that we didn't did it right now because it takes around 10 to 12 minutes. We don't have that much time. So please use this command. It will give you all the details about that particular machine, target machine, like their OS, BIOS details, and network card details, and everything. Okay, use that too. So that was it, guys. Thank you. I may now stop presenting it, I guess. Yeah, and please join subsequent following classes too. If in any way you didn't understand some topics today, it's all right. You can just do a little bit of homework, ask questions in the group. I hope you all have joined a WhatsApp group. Thank you, so great. Yeah, thank you, Fareed. Thank you, Priyanshu. So you can ask the questions in the group, and our instructors will help you whenever they are available. Thank you, Sagar. Thank you, Subha. Yeah, Vandana. Thank you. Thank you, Tanvi. Yeah, so make sure you attend all the following classes. I know it was a complete new to you, so you may have certain doubts in you. It's all right. You can just ask questions. Take time to digest these all new topics. Do a little bit of homework on your own. Okay, because this is a self-learning path you have chosen. You may have to do a lot of self-learning, especially about networks. Make sure ethical hacking or pen testing or any subdomain is nothing without networking. Go through networking. Okay. All right. So thank you everyone for joining in, and we'll see you in the following lectures. Bye bye.